lesson 3 is about rhombuses, no, not about rhombuses, about trapezoids and kites. And we're going to start with number 2 and number 4, which shows a diagram of a kite. So number 2 and number 4. All right. In this diagram of this kite, angle QPR is this entire angle right here, and that angle is congruent to the angle opposite, angle QSR. And that's one of the properties of a kite. Opposite angles, actually not full pairs, just these two opposite angles are congruent. Okay, what we do know is that these two angles right here, this angle at this end and this angle at this end, are not congruent to each other. So we can find the value of those if we knew some of the angle measures. And in number 4, we're looking at angle PQT. Angle PQT is this angle right here, and it is congruent to angle SQT. And then we're also taking a look at angle PRT. PRT is this angle down here, and it is congruent to angle SRT, this angle right here. And in the next few questions, 5 through 8, we're now taking a look at a trapezoid. And in number 6, they're talking about the base angle. So one pair of base angles is angle X and angle W. And those two angles are congruent to each other. The other pair of base angles are angle U and angle V. They are congruent to each other, but they are different than angle X and angle W. The vertices of the trapezoid are U, V, W, and X. Number 10, the length of WY is 10 inches. And this figure is an isosceles trapezoid. They're wanting to know the distance from Z to X. What's the length of ZX? And that distance is also 10 inches. And the reason is, in an isosceles trapezoid, the diagonals are always congruent. Number 12, we have a diagram to the right, which is a photograph of a chest of drawers. In the diagram, HC is the mid-segment of trapezoid ABDG. So HC is in the middle, or the mid-segment, of this trapezoid right here. GG, or GD, is the midsegment of trapezoid HCEF. So this is the midsegment of trapezoid HCEF. AB is equal to 13.9. And GD is 50.5. First thing we're going to find is segment HC. So to do that, I'm going to take 13.9 and we're going to add that to 50.5, and then we're going to take half of that, we're going to divide it in half or average it to find the distance from H to C. Then the last length we need to find is the distance from F to E. So, if we know that the midsegment is GD, we know that that's equal to segment HC plus segment FE, which is what we're trying to find. And if we average those two or divide those two by 2, that gives me the answer of 50.5. So the question is, what number together with 32.2 divided by 2 is equal to 50.5? So we're going to solve this equation as if it were a proportion. And I'm going to cross multiply. So 50.5 times 2 is equal to 32.2 plus segment FE. Now we're going to check our answer. We're going to add segment HC plus segment FE, divide that by 2, and the answer should be 50.5. In number 14, we're given a diagram, and the question is, is there enough information to say that this is a square? The answer is yes. It's definitely a square, and there's many ways to explain this. But because you recently studied 45, 45, 90 triangles, you will see that each of these triangles is indeed a 45, 45, 90 triangle. And the reason why we know that is because we have two congruent sides, so that means we have two congruent base angles. So because we have four congruent 45, 45, 90 right triangles, then we know that all the sides are the same measure. So we can now conclude that JK is congruent to KL, which is congruent to ML, which is congruent to JM. We also know one of the properties of a square is that the diagonals form right angles. So we see the right angles here. The diagonals form right angles. And then another property of squares is that the diagonals are congruent to one another. Number 16. The tabletop that we see here is an isosceles trapezoid. And what I know about isosceles trapezoids is that both legs are congruent to each other. And in this trapezoid, segment AB is 48 inches. Segment BC is 19 inches. Segment CD is 24 inches. Because it's isosceles, AD is also 19 inches. And they want to know what is the length of the mid-segment. And the mid-segment would go through the middle, parallel to the top and bottom base. The question is, what is the measure of this side here? So to find that mid-segment, I'm going to take my two bases, 48 and 24, add them together, divide by 2, and that will give me my mid-segment. Okay, and looks like we have some review questions because we are now being asked to graph the vertices of parallelogram ABCD. So let's take a look at point A. Point A is -2, -3. Point B is 4, -3. Point C is 3, 2. And the question is, where could point D be located? Well, point D can be located in a couple of places. It could be located somewhere over here. That would be one location. And to find that location, we're going to try to zoom in on that. I'm going to do a little counting. So to go from point B up and over, use a little dotted line here. Point B, I'm going to go up and I'm going to go over. I went up 1, 2, 3, 4, 5, and over 1. So I'm going to do the same thing here. 1, 2, 3, 4, 5, and over 1. And so my first location can be right here. So that's one of my locations for point D. parallelogram if I connect these together. All right, so there's parallelogram number 1. And so point D would be at -3, -2. Now there's another location. Besides -3, -3, +2. I hope I wrote that right the first time. -3, +2. Okay, that was right here. That's one location. But there's another location. I can actually take this point. Let's just see if I can grab the point. And I can move that point somewhere down here to make another parallelogram. And to help me with that, I'm going to count. I'm going to count from A to B. And that's 1, 2, 3, 4, 5, 6 units. And so I'm going to do the same thing here. I'm going to count 1, 2, 3, 4, 5, 6. So it was a little bit off. So I'm going to move this point right back here. And that's my second point for D. That makes a parallelogram. And so we can call that 1, 2, 3, 4, 5, 6, 7, 8, 9. And up to would be 9, 2. Now that we've studied all the different types of quadrilaterals, this is a great way to organize and think about what quadrilateral families belong to each other. So I'm going to begin by, first of all, putting the kite family, which is all on its own inside this circle. And inside this region, we have the family of trapezoids. And within the family of trapezoids, we have isosceles trapezoids. And they're just a special type of trapezoid. Now that leaves parallelograms, rhombuses, rectangles, and squares. And all of those figures that I just mentioned are considered part of the parallelogram family. So this last great big family down here is the family of parallelograms. Within the parallelogram family, we have rhombuses, rectangles, and squares. One family is the family of rectangles. The other family is the family of rhombuses. And the square belongs to both the rectangle and the rhombus family, and obviously is part of the parallelogram family. Okay, so in a kite, what we have some right triangles. One of the properties of a kite is that the diagonals are perpendicular to one another. In other words, they form right angles. So as you can see, we have several right triangles that are formed. Let's take a look at this right triangle here. In that right triangle, I know that this leg is 3, this angle is 55 degrees, and I want to find the value of x. To do that, I can use trigonometry. And because I'm trying to find the hypotenuse of the triangle and I know the side that is adjacent to the 55-degree angle. Adjacent and hypotenuse uses the trig function cosine. And cosine is adjacent divided by the hypotenuse. So the adjacent side is 3 divided by the hypotenuse, which is x. Now the last thing I need to find is the measure of this angle right here, angle Z. And what I know in all triangles is that the sum of the angles is 180 degrees. So if I want to find the measure of angle Z, that's equal to 180 minus 90 degrees minus 55 degrees. To help me to find y, I'm going to use this little triangle right here. And in this triangle, I know that this side is 3, and I also know that this side is 3. And here's why I know that. In a kite, this diagonal gets bisected. So if this segment from here to here is 3, this segment is also 3. So that diagonal gets bisected by segment AC. Diagonal BD is bisected by segment AC. So if I have a right triangle and the two legs are 3, then the hypotenuse is 3 times radical 2. That's a 45-45 right triangle. And I can also use the Pythagorean theorem. So I could have said 3 squared plus 3 squared is equal to c squared. So whichever way I solve it, side y is 3 radical 3.